All right, the recording has started, so good morning, good evening, or good afternoon. Thanks for joining this instance of the Antrea community meeting. For today, we have two topics in our agenda. Chan will give us an update on follow-up items for the Layer 7 network policy work that he's leading. And Lan will then give us an overview of policy-only support for multi-cluster. So I will that's our agenda for today. Then we will have some open discussion, and then Chan, over to you for Layer 7 network policies.
Thank you, Salvatore. Thank you everyone for joining this meeting. We presented the proposal of Layer 7 network policy a few weeks ago, and there were some open items. And in recent weeks, we did some investigation, and I and Hongliang will share some results and some still open questions for discussion. The first is API name. Currently, in my PR for the 7 policy API, I just use the first name, and I think this we could just discuss this in the PR itself. So let's go to the second directly. For the second question, in my current patch for the API, I didn't set the port field, and mainly because we don't support traffic control to redirect or mirror port specific traffic only. It has to be the whole traffic or for a port or not. So even we have this field in this release, it will not help the performance much, and it would limit the protocol will only work. The policy will only work when user use one port or the specific port range. So I didn't have this. I didn't have this port field in this release, and the host name will only match the host field will only match the host name in the URI or the host field in the HTTP header. In the future, when we start supporting, when traffic control starts to support traffic redirecting traffic specific to one transport port only, I think we could consider add this port field as an optional field. And for the second one, this includes several problems. For example, I found that for a egress rule, if we just drop all other protocols, all traffic of other protocols, the egress Layer 7 network policy will not work, because when we use domain to specify the destination URL, the workload has to resolve the domain to IP, so it has to use DNS protocol. So, but if we don't support DNS protocol in the first release, basically the egress layer policy will make the client doesn't even have a chance to send out the HTTP request. So previously, I remember my design was that if we had two choices, that when users specify one protocol in the Layer 7 network policy, what happens to traffic of other protocols? One option is that we ignore other protocols, meaning that all other protocol will be allowed by the 7-layer policy. And another option is that we drop all traffic of other protocols. It's more like the second choice. The second option is more like the current Kubernetes layer policy, that only the listed protocol will be allowed and all others will be dropped. So if we go the second option, it will have this problem, and it has another problem that even with support DNS protocol in this release, is still the second option is still not friendly when a workload use more than one protocol, and one protocol is one of them is supported by the 7-layer policy. Another one is not supported by the 7-layer policy, because with that behavior, the unsupported protocol, the traffic of unsupported protocol will always be dropped. So that's the problem of the second choice. But if we go the first choice, that you just ignore other protocols, we don't have a good solution to support a scenario that user want just to allow HTTP protocol, but no others. Yeah. So I'm thinking about two solutions to fix to support to better support the use cases. For one, it's like we go option 2, but we add DNS protocol support in the first release together with HTTP protocol. In this way, so user could specify two protocols. One is HTTP and which contains the path and the method and the host name and they want to use. And another protocol is DNS, and it should repeat the it should also have the domain name as the field of the DNS protocol to say that it only allows the client to query the domain, the IP of specific domain. This is one option, and it doesn't resolve the second problem. But if the second problem is really a problem, I also propose the first option because I'm thinking that either a pod should focus on a specific application, so it shouldn't use many protocols at the same time, especially when it serves as the server. So when it serves as a server, when we define the ingress, the 7-layer policy, just one protocol for HTTP, just one HTTP protocol should be enough. And for applications that pods runs as client, there might be some other protocols being used. For example, one may access other servers, web API, and it could access DB service at the same time, but the DB service are not supported as for the time being. So in this case, they could the 7-layer policy may not work for them. That's one limitation of the first option. And then the second option is that we introduce a field like protocol mismatch policy, and it has two values. One is drop. It is just like the second option I just mentioned, that we just drop all traffic of all other protocols, so that you can achieve allowing HTTP protocol only with one policy, with one layer 7 nail policy. And another value would be ignore. And it means the layer 7 nail policy would ignore traffic of all other protocols. For the previous case, if the port runs as a client, it wants to access a specific HTTP service. At the same time, it wants to access some DB service, but the DB service is not supported. With ignore, it will the DB traffic will pass layer 7 nail policy automatically, and the user could use layer 4 nail policy together with layer 7 nail policy to limit to have some restriction about the traffic, whether which port and which destination the client could access. So currently, there are two options to resolve the some of the problem. I think the first one is more Kubernetes nail policy style, and it's simpler, but it would introduce it may introduce some use case we cannot support until the protocol support is very rich. And the second could address all cases, but is not this field. We don't have this field in previous nail policy APIs, so it's something new. And anyone has suggestion or questions about these two options?
I have a question for your option 1.
Yeah.
I was thinking when you say the policy will drop traffic of the protocols not specified, that should mean the policies, the supported policies, right? I mean, for example, if we only support HTTP, that means actually we'll not drop any other protocols. Only when we support both HTTP and the DNS, at that time you can see if DNS not specified, we drop DNS traffic. That is my understanding.
I didn't mean that. If in that way, then the layer 7 nail policy's meaning will change whenever we support a new protocol, right? For example, we don't support DNS protocol in this first release, and it was not dropped in the first release. And after user upgraded to the second release, and we add DNS support, then the same policy will drop DNS protocol. So I
in that sense, even for layer 4, do you think that's the case? For example, today we support TCP, UDP, HTTP.
Yeah.
For later, if you add a new policy like IGMP or ICMP, then that let me see.
The Kubernetes nail policy and Antrea nail policy is more like the option 1. When we don't support ICMP protocol, there's no way to allow ICMP traffic when you isolate the port.
So you're saying today it's like once you define a live policy, all the unsupported IP protocol will be dropped?
Yes, with
really?
layer 4, nail policy. Yeah. You know, people Kubernetes nail policy still only support TCP and UDP, and with Kubernetes nail policy, there is no way to allow SMP traffic once any nail policy applies to a port.
Okay.
If you want to test PIN, you can only remove all nail policies from the port.
Then the problem is, how could you know the full set of layer 7 policy you want to support now?
That's the problem. So and that's why I proposed another option which is not similar to Kubernetes nail policy style. For Kubernetes nail policy, therefore, there are only three major protocols, right? So it's easy to enumerate all, but for layer 4, layer 7, there are too many, and in this case, if supported and unsupported protocol are used together for workload, user cannot use the supported protocol if we go the first option, because all unsupported protocol will be dropped.
Okay.
The option 2 is just add a field to change the behavior. The default behavior could be same as the Kubernetes nail policy, but we add another one to allow to ignore traffic of all other protocols. So when we don't support them, yeah. Go ahead.
I don't understand this. I mean, how you define what other protocols? I mean, do you mean the protocol supported by Suricata or
any protocol that doesn't match the listed protocol in the object in the layer 7 nail policy?
But how you know the path is the other protocol? That I didn't.
We just use IP to match the traffic, because this is a blacklist mode, right? This is a whitelist mode. Once the layer 7 nail policy applies to a port, if we go the first option, there would be a rule to drop all IP packets to this port. For example, if this is ingress, we will have a deny or a drop rule to drop all IP traffic.
Sure, but I remember you said in the first version will not support port, right?
I mean port. We use IP to match
okay.
Yeah. So only the protocols that used in the layer 7 nail policy, we will add a allow rule. So except the HTTP protocol, all IP traffic will be dropped.
I'm a little confused. If I have a layer 4 policy, for example, to allow ICMP, and once you define layer 7 policy, does that mean ICMP cannot be allowed?
It will not be allowed. Layer 4 and layer 7 nail policy are enforced individually. Layer 4 are enforced first, then layer 7. If we mix them, then the layer 4 you already allow layer 4. For example, with layer 4 nail policy, you allow TCP 80 port traffic, right? It already allows the traffic itself. So if we are not enforced, then the two kinds of rules, first and later, it doesn't make sense that the second could drop the traffic, right? So they don't affect each other. It's just one is enforced first, then the next one. So if a packet is already dropped by the layer 4 policy, it will not even get into the layer 4.
But we're talking about I'm talking about the allow case, right? If you have a layer 4 policy to allow ICMP, but once you define layer 7 policy, do you mean ICMP will be always dropped?
Yes.
I think that looks a little strange. Probably later we should merge the 7 protocol to a layer 4 protocol. Is that true or not? Okay, I'm not right.
That could be a way. If you are your example is your point is about non-layer 7 protocol I think they could be fixed. That we just need to make the layer 7 nail policy to focus layer 7 protocols based on TCP and UDP.
No, I think the problem is like how do I describe it? I think the problem that for some, like for example, if we just talk about TCP, it's possible you have both layer 4 traffic and layer 7 traffic, both use TCP. For the ones you define layer 7 policy, actually you cannot allow any other long layer 7 traffic to the port. You got me. For example,
But
if I have a
that,
HTTP, I also have a layer 4 heartbeat, I have no way to define the policy to allow both.
yeah, that's the second problem. Yeah, unsupported protocol when a workload use them together. Yeah, that's the problem of. I understand that. So that's why we could consider the second choice. If we don't know the protocol or we don't support the protocol yet, layer 7 layer policy would just ignore that traffic. I think this could address your problem.
Maybe I can think of another option. For example, if we can mention the TCP and the UDP port in the ingress and the egress rules, and then you can define a policy, something like I want to allow the specific TCP port, but I don't know the layer 7 policy. And then this is because usually one TCP and UDP port is used for only one kind of layer 7 policy. So maybe you can enumerate all of the ports you will be using in this pod, and then define a layer 7 policy for the ports that we still don't support the layer 7, but we can support for TCP.
You mean like this?
Yeah. We can, for example, remove the HTTP path and method and only mention the port 80, or for example, 443, 22, and then it will be allowed. And then we don't support, for example, SSH as a application, but we can still allow the port 80. And then we can block all of the ports.
In this way, how we support allowing only HTTP protocol, but not other traffic?
I think we can still use the same way. The port number is not mandatory. So
that means that the port, whether the port is set, would affect whether other protocols or other, for example, does this affect the UDP based layer 7 protocols and other non-HTTP protocols? Would this affect them with this port specified or not? I think that would also means the isolation would be per protocol, right?
So for example, if you set port and HTTP here, it allows HTTP only on this port and block all the other ports. And then if you have another rule to allow port 81, and then all of the protocols on TCP port 81 will be allowed. And the other ports are blocked. If you have for example, another example, if you have a HTTP without port, and then you have a rule with only port, for example, 81, and then 81 will always be allowed, and the other ports will be inspected to check if it's a HTTP, and then it will be dropped if it's not. Can this be done? So then we maybe, yeah.
Let me think about it. I'm trying to understand the meaning of
Yeah,
this.
I think if we go this way, this port number is not a match criteria for this rule. Actually, it's to define the scope of traffic to go through layer 7 enforcement chain. That's
Yeah,
my
yeah.
take. So
I understand.
I think that should. Let's see.
So it would mean that with this no, maybe we need to have less indent for this port field. But anyway, with this rule defined, it will only check TCP TCP to port 80 traffic, and if it match this HTTP attributes, it will be allowed. Any other traffic that match TCP 80 port will be dropped, right? And all other TCP port traffic and UDP traffic will not be affected by this layer 7 layer policy. Is that what you means?
I mean that if with this, all of the traffic on the other ports, be it HTTP or not, should be dropped because it's an isolation. It's a allow list.
This doesn't match. This cannot resolve the use case Jianjun raised, right? If they are dropped.
And then if you want to allow some unsupported protocol, you just add another entry and with only port mentioned without any layer 7 protocol. For example, TCP port 443, and then, TCP port 22, and then even we don't support SSH, and we can just allow every protocol on 22 and block all the other ports.
I understand, but that was I tried to avoid. It would be a little duplicated with our current layer 4 layer policy. So you need to allow the same layer 4 protocol and port twice in layer 4 and layer 7. So that was I wanted to avoid, to have the same same information in the 7 layer policy. So you see that if you have this, you have to.
So maybe the second use case, for example, if you don't, you only want to allow HTTP and block the other protocols, we can use the layer 4 policy for that. And then in layer 7, you can allow everything on the other ports.
Yeah, so
for unsupported protocol. Yeah.
This policy would mean that it will, the layer 7 layer policy would hand TCP port 80 only, and if it matches this attributes, it will be allowed. If it doesn't match the HTTP attributes, it will be dropped, and all other port will not be affected, right?
Yeah.
And if we don't specify the port, then it would mean all traffic, all TCP port, or even all UDP port will be denied if they doesn't match the HTTP protocol. Is this whether you and Jianjun would agree? So this is a limitation.
I need to think about it a little more.
Yeah.
I didn't spend time to think about this issue before. So.
Okay.
Yeah, Father, I was thinking this something like this actually defines the traffic redirection and for traffic meter scope. It's not part of a rule matching criteria. It's more like a traffic direction criteria.
Yeah, I understand. Yeah. Okay, we could discuss more offline and or in the PI itself. And this is the this problem. And for the checksum offloading issues, and as I mentioned before, the traffic, once it is handled by the Layer 7 engine, the traffic would be sent to data plane from user space by the Layer 7 engine, and some of the bits in the package SKB is changed, and the destination will not accept the package because the checksum looks not correct. And we investigate another option, except the one is already working, but may affect all ports and has to be turned on from once the cluster is deployed. Then the other option is that we could use TC-sum action to force recalculate the checksum of specific packets, and we only need to set this configuration in the network device used by the Layer 7 engine to send traffic. So only for the existing solution, all traffic will be affected, but with this new solution, only Layer 7 error policy and applied traffic will be affected. It's a little better than the other one, but not resolving the issue completely. Hong would share more investigation about this mechanism later. And he also verified that this could work for a newer kernel, but not older one. And I remember we have also this question, that what's the effect if the name policy use FQDN? After some consideration, I feel that it may not make sense to let the 7 node policy to use FQDN as the destination, as the name policy peer, because if user want to restrict the client to only access a specific web service, they could use host name in the Layer 7 protocol attribute, but not has to specify the net policy peer. And it could to be more safe. They could also specify DNS protocol to only allow the client to query the same domain, but this is not really needed, because if user access other domain names, the traffic would have already been dropped, even without the IP matching. Hope this makes sense. And next question is about what if a signature has a lot of discontinuous IP? There would be two problems. One is management issue, that if we, for example, for a Layer 7 name policy, we have address group and apply to group. There could be many IPs in those groups. If we just repeat the IP in the signature itself, a single signature would be very long, and there would be many duplicated information in the signature. I tried to use the variables in the signature, and I verified it could work. That instead of listing all IPs, we could define an address group. It's also called address group in Suricata. The address group could refer to a list of IPs, but before Suricata 7, which is just released a few 2 weeks ago, I think. Before this release, there is a limitation that the address string must smaller, shorter than 8K bytes, and it would only include more than 500 IPv4 addresses, and this issue has been fixed by this PR, and the current release 7.1.0.0 beta 1 already include the patch, and I verified that from this release there could be unlimited address included by one address group. And also with this, with the use of the variable, it's possible that the rule, the signature file is static, and we only need to update the configuration file which contains the address group member information, and ask the Suricata instance to reload the whole rule after that, after updating the variable. So in the case of no policy change, but just port lifecycle events, only the variable file would be updated. The signature will not change. And another is performance issue. What if we have many IPs in a single signature, and what if we have many signatures converted from the 7-layer policy? Their performance impact, and Hongliang will share more information about them. Thanks. Hongliang, could you take it over? Let me stop sharing.
Sure. Wait a minute. Wait a minute. I have data to update in just a few seconds.
If anyone has anything want to discuss about the issues, please go ahead.
I think we can go ahead, Sean. Sorry, I'm not sure what's the next topic. Is Hongliang going to present something?
Yes, Hongliang
Okay.
has some data to share.
Okay.
Yes, yeah.
Okay, I'm
Okay.
ready now.
Okay.
Hello. This is the data about the signatures of Suricata. This is the Suricata. This is the signature numbers, and this is the source IP per signature, and that's the IP per signature. This is the time cost. This is the cost of time to reload all these signatures. We can see that when there are 32 source, and that's the IPs in per signatures. With from 1,000, 2,000, and 5,000, even 10,000. We don't need a very long time to reloading our signatures, but with the increase of source IPs and DAS IPs per signatures, the cost of reloading time increases. We can see that. We can see this line when there are 2,070, 75 IPs per signatures. It takes 7 seconds to reload our signatures. Any question about the data?
So from this data, I think is the management performance is okay, because on each node there should be at most 1,000. I feel, because there are only a few ports running on a port, and there might be a few numbers of there are 7 ports applied to each port. So I feel perhaps hundreds of signatures is the all we need. And from your data, it could be less than 1 second to read all rules, right? So I think it should be fine.
Okay, thanks, Chen. Any question about this? If no, we can connect
So I'm
to the
sorry.
benchmark.
So I'm a bit
Please
curious
go ahead.
about, for example, if we only have a few signatures, but in some of the signatures, the IP addresses numbers are really huge. For example, 1,000 or 2,000. Maybe we can also evaluate this.
For this, as mentioned by Chen, we have some limit before 7.3
Okay.
3 version 7. We have to split a very huge IP range to into 2 or 3 1, because for CAD you can see that we can have most about 500 IPs per signatures.
Got it. Thanks.
Okay, then we can go next. And this is the benchmark data about Suricata with different signatures. This test environment have just the 2 ports. They are disabled with checksum TX checksum offloading, and there is a Suricata port with host network. They are all in a node. I just use the default argument for every payload. And every test is calculated from 10 run tests, remove the lowest and highest, then get the average. Sorry, I need to remove this. I have before this practice, I have changed the Suricata argument. So we can anyway we can see that without Suricata, this is the payload data. Then the auto, and then we can with Suricata. This is a very small scale. There's only 102 signatures. The thread is auto, and this is very important because if we set it manually as 1 or 2, some test is affected. It is very like this. This like a TCPR and TCPCR is affected by threads. The thread is related with CPU numbers. Okay, we can see the with auto with thread auto. The TCP stream and UD stream is almost about maybe about 50% of the. That's the 50% of the original one, and we can see like this. Of course, we can see another condition. There are 2 signatures which are used to match the payload, and without this due to the limited of time, I didn't test them all, but we can see this part is complicated. We can see there are only two threads. This is we can see these two tests are affected, but I set it to auto. They looks much better, but they are also about 50% of the original data. And another difference is about for Stricata signatures. There are for this one, there is no signature can match any payload of this. For this one, there are two rules. There are two signatures which are used to match the payload of TCP stream or UDP stream and the TCP-R. When they are matched, when there are signatures which matches the payload, the test payload, the data is a little better for TCP stream and other like TCP-R and the TCP-CR. Other like for this is the biggest scheme with the most IPs and the most 10,000 signatures. We can see that the data of TCP stream is also decreased. Okay, any question about this?
No question from me. Does anybody in the team has any question for Hong-Liang or Chan? Okay, so if you have a question, please speak up now. Otherwise, in the interest of time, I would like to ensure that Lan has at least 10 minutes to go over the discussion of policy only for multi-cluster. So Lan, I'm sorry, this might not be enough time for you. So perhaps we can start the conversation on this, and then if needed, we can follow up in the next community meeting. So yeah, thanks for waiting, Lan, and please go ahead with your presentation.
Yeah, okay, thanks. So, and can you see my screen?
Yes.
Hello? Okay, cool. Okay, maybe I can just give a quick overview of the current design. And okay, hello everyone. And before we discuss about network policy only mode, I'd like to show you that about multi-class traffic when we're using it with the in-cap mode, which is the default mode we are using for the enabling the multi-cluster feature. You know that in our Antrea multi-cluster, when we have a multi-cluster service which exported in one cluster, for example, member cluster, here we have three member cluster, and another core service is our multi-class service. We will define a service in the imported cluster, and it will have this kind of prefix. And the special case, the special point for the multi-class service is that we will no longer have the pod IP as the endpoint. We will using the remote exported services cluster IP as the endpoint. So if you see here, these two IPs, actually those cluster IPs are assigned in their own cluster. For example, in class B, this is 1.20. 12. And okay, you will see that in class C, and it will have this class IP. So for the in-cap mode, we will use class IP of exported service as the endpoint in import service. And if you go to see the traffic, you will see that we have 2 DNet and 1 SNet. All of the cross-class traffic will go through the gateway and do the SNet before it goes out of the cluster. So I guess all of you should be familiar with this traffic model. So maybe I just give you an overview of current in-cab mode. And you know that in-cab mode, we managing our class pod IP and also the traffic, we all go through the tunnel interface, right? But if we go through the policy only mode, the problem is that we would have some gaps here. One thing that there's no tunnel interface because there's no longer needed, and all the traffic or the pod IP is managed by the primary CNI, and also the routes is set up by the primary CNI. So our assumption is no longer, or I would say the prerequisites is no longer supported in network policy only mode. For example, here in one cluster, there's no longer have tunnel interface, and those in-class traffic is also controlled the primary CNI and by the cloud provider. So here the in-cluster tunnel and the interface is no longer existing here. This is a gap we have in the network policy only mode. So how we can fix this gap? The main works are actually in the entry agent. One thing is that we need a tunnel interface. So we need to set up the tunnel interface, even we run it in the network policy only mode. And even it's by default, there's no tunnel interface. So we will create a new tunnel interface. It's only for the cross-class traffic. This is one thing we need to do from the entry agent. And another one is that, there's a gap. There's no in-class routes for the pod IP, and it's out of our control because it's controlled by primary CNI. So we need to set up those pod routes and from the gateway to general nodes and let it go through the tunnel interface. Okay, here, as you can see that the gap is here. If you see the first one, the green one, it's actually the in-cab mode. So we will have something like the default level 3 forwarding rule. And this CIDR will be the pod CIDR, right? Sorry. Okay. Okay, we think that it will be the pod CIDR. Oh, sorry, this is in carbon. The service side, it's actually the service side, remote service. This side belongs to the remote class. For example, this side is from class B. And we know that this side and this belongs class B. So we will forward this from the gateway to forward the traffic to the class B. Okay, when we goes to the network policy only mode, and the same rule will be there, and there's no change for this part. But when the traffic hits the class B, or we see the cross-cluster traffic has reached the class B. In the class B, when we run it in-cab mode, we will have something for the pod IP, and we know how to route those pod traffic to the right node, right? Because we have some level 3 forwarding rule here, and we know the remote or the other general nodes CIDR here. But in network policy only mode, we don't have this kind of a forwarding rule because the pod IP is not controlled managed by us, and the route is on their underlay network. So this is one puzzle we need to fix. Okay, so in how we can, so when the request or cross-cluster traffic request goes out to another cluster, for example, here we reach the class B, how the gateway know how this traffic goes to the right node? We will add something we will add a new controller in the entry agent to set up a necessary part routes between gateway and the general node. But we will only watch those exported service backend part and its corresponding endpoints only. So you will see a new rule in the level 3 forwarding, and the destination will be the pod IP, and we will set up the right tunnel destination IP for the cross-class traffic. Sorry. So before you will see that we have a CIDR. Sorry, here we have a pod CIDR to control which node this traffic should goes to. For now, we will just set up a necessary pod IP here in the level 3 forwarding. And okay, this is one puzzle. Another puzzle is that when the traffic, let's say the traffic from class B, it's reached class B and let's go back to the class A. In the class B, we will have in cab mode, we will have level 3 forwarding and understand that the traffic, that we have SNet. So we know that this IP is from remote cluster. We know the destination is matching the remote class IP. Then it goes to the right. It will go back to the gateway and go back to the pod client. Then there in the network policy only mode, there actually no difference here. But when the request, the replied package go back to the class A in in-cab mode, as before, we can tell that the same through the same way. There's a level 3 forwarding pod CIDR here, right? And we can just send it back to the based on the pod CIDR. But for now, in network policy only mode, it has the same problem here. We don't have such a level 3 forwarding route here. So how we can fix in the request cluster? Okay, here's how we do that. That in reply direction, we will need a way to let the gateway know which general node the traffic should send back, right? So we use a city label, a new label here to save the request package's source tunnel IP when the request arrives gateway at the beginning. And so you will see something like this. It will match the destination and also load the necessary registry, and also we save the pod source IP, tunnel source IP here to new field here. And after that, we will also make sure the cross-class traffic, we commit the source IP, tunnel IP to the label so that we can use it later. Then after we save this, when the replied package come back to the gateway on the class A, it will filter and match based on the city label. Then it will set the right tunnel here, based on the IP, and of course in the city label, and save or load the right tunnel destination IP here to the tunnel destination. Then it will go back to the right general node. Yeah, I think that's all for the core function for core part on the multi-cluster with the network policy only mode. And I'm not sure if there are any questions here.
Hello, so is there any question for Lan? I understand that we are already at time, but it would be nice to spend a few minutes discussing this feature. So if you have any question, please go ahead. Okay, so to be honest with you, Lan, what you discussed makes sense to me, but I probably I would like to review your presentation and read it better. Is this already shared somewhere?
Not yet. I think maybe I can create an issue on the GitHub and provide the details there.
Cool, thanks. That would be great, yes.
Okay, thank you.
Okay, is there any additional question, comment, any feedback for Lan? I'll probably wait 15 to 20 seconds. And then if no additional question, we can close this meeting here. Okay, it seems that that's all for today. So I would like to thank today's presenters, Lan, Hongliang, and Chan, for such good presentations and a very good discussion. And I'm looking forward to see more conversation both about layer 7 network policies and policy-only mode for multi-cluster. So thanks a lot to everyone for attending, and let's meet again in 2 weeks' time. Thanks, and I wish everyone a good day, a good afternoon, or good night.